So hi everyone, my name is Sarah Stanley and you are in the Introduction to R workshop in this STEM data series. My name is Sarah Stanley, I'm the Digital Humanities Librarian. I usually do work over at Strozier. So as the Digital Humanities Librarian, I end up using R a lot, mostly for text analysis. So I mostly do text-based research, and actually we're just wrapping up a series on R for text analysis. The last session's on Friday. If you want to come to that, it's topic modeling. All of that, though, is to say that my expertise is not in STEM data, and so I also do not have a background in statistics. So if you came here today to learn deep statistical stuff, I'm sorry, I'm mostly just going to be teaching you the R environment and basically how it all works and how to load data into R and kind of get used to the whole R Studio system. But that said, I hope that you find this useful. So for today, I don't know how many of you brought your own computers, but I know that the workshop materials did say to download and install R in RStudio. We will find time in the hands-on to do that if you haven't already. And is it installed on these computers? Okay. And so we're going to be working with a CSV that I found on just this government data catalog. That's at that bit.ly link, bit.ly Dirac R. If you go there, you're going to see a page. I'll leave it up for 1 second while y'all get that link. And you should come to a page that looks like this. This was just, a data set that I found at data.gov. You're going to download this first link right here, and it should get you a CSV with a rather long title called Total Biofuels Production 2000 to 2010, 1,000 barrels per day.csv. It's wordy, but this one is the data set that we're going to be using for today. And so once you've downloaded that, if you could move that somewhere where you can find it easily, preferably inside of a directory that you can find easily. So I have mine inside of my desktop in a folder called RSTEM. So this is just going to help us to set our working directories, and we'll talk about that in a minute when we get to R. Then what you're going to want to do, that is the CSV. Does it have country names and a bunch of data? So when it says download, if it doesn't automatically download it for you, what you're going to want to do is right-click, and then it should be save link as, but maybe, or save file as. Bring up that link again. It should automatically download it for you, but if not, just right-click on that download link and see if you can save the file as. Okay. Save it as the name that it's been given. It should be that CSV. All right. So we will have time to go back to this when we do all of the setup. So I'm just going to go back to my slides, and we will do a little hands-on in a second where I can come around and make sure that you all are good with that data. So I just wanted to talk a little bit about what we're going to learn today. So we're going to learn the basics of the RStudio environment, and we're going to learn how to use the R console. We're going to get a little bit into packages, but we're not actually going to use any packages today. Packages are essentially extensions of kind of the core RStudio that allow you to do some specialized things. So for example, when I do text analysis, I use a package called text mining. You can find packages for almost any type of research that you might want to do. We'll just talk a little bit about those. We're going to learn how to load data into R. And then we're also going to learn about data cleaning and some basic functions. And by the end, we will have created a basic R plot. So just a little overview of R. And so let's actually get into the R Studio environment and take a little look at what that looks like. Okay. So what I'm going to do is if you just open up RStudio, which is this icon, it might not be in your sorry, it might not be in your doc like mine is, but just open up RStudio, and you should have something that looks a little bit like this. I can also make it bigger if folks need. Is that big enough for people to see? So You may have also opened it up and seen, instead of 3 panes, you may have seen 4 panes. If for those of you who see 3 panes like me, if you just kind of go up to this green plus with a page and click on R script, or you can do that Command Shift N, but it'll bring up a 4th pane in the top left. So let's just talk a little bit about what these different panes do and what they're for. So in R, we have this scripting pane, and for me, this is in the top left. And basically what this place is for is where you can edit your R scripts without necessarily running any of the code. So this is really great for multi-line scripts, like if you were to ever do like for loops, where there are a lot of moving parts and you want to edit things before you run everything as a block. And this is also a really great way to save your code. So you're probably going to be saving these R scripts for use again later. So this is probably like, when you have like, a my data analysis.r file, that's going to be up in this pane. That's the file that gets saved. The console is very, very important because that's actually where the data that gets run is being stored. That's kind of like, the command line, if you've ever used a command line on a computer. So what you can actually do is, you can treat it like a calculator. So we can all try this together if you want, but you can just run like 2 + 2, and it'll give you 4, right? And so, that's a rather simplistic one. And you can also, do that with like 10 divided by 5. You can use that slash. And that's also at 2, and you can do that with stars, multiplication, minus, etc. And so that's actually where you're going to run the data. So say you want to run something that's up in your scripting pane and send it down to the console. The way that you're going to do that, and we'll try this again, but with 20 minus 8, instead of just hitting enter, if you just hit enter, it's just going to create a new line for you to write more of your script. All you're going to do is you're going to do either Control or Command Enter, and it'll send whatever you've written up in the scripting pane down to the console. So I will try to gloss this as much as possible when I do it in real time. Stop me if I forget. But sometimes I will be editing things up in the scripting pane, especially stuff that I want to save, like if I'm creating an object, and we'll talk about those in a second, or if I'm doing something a little bit more complex that I want to save for later, I tend to do it up in this script pane. But sometimes when I want to check things, like I want to check the length of a list, like how many items are in a list, I might check that down in the console because I don't necessarily want it saved up in my script. And I'll, again, try to be as candid as possible about when I'm doing that, because that can get confusing when you see people doing both. You're gonna, this paper-looking thing with the green plus sign, if you click on that and hit R script, that's going to open up a scripting pane for you. And that's where we're going to be saving all of our code. Okay. And so there are these 2 other panes over here that right now look pretty empty, but I do want to go over them and talk a bit about what they are before we move on. So there's this environment, history, and connections pane. Environment is a really useful thing because it keeps track of all of your stored objects. So for example, if I want to, I'm going to create an object called, you can go type this along with me, but it's going to be called test.v. And the way that we create an object is with a less than sign followed by a hyphen, so it kind of looks like a little arrow. And then what I'm going to do is, in quotes, do the kind of stereotypical coding thing and say, hello world. And so if I hit Control Enter, what we see is that our environment has been populated with this hello world object. And so that we've saved something so that we can call it in different contexts. So instead of every time we want to reference the character string hello world, we can just say, okay, test.v, and it'll print down the console hello world. So it's storing that object. This is also useful for if I want to say like my nums.v, .v. I'm going to, again, assign that variable by doing less than hyphen, and I'm going to say concatenate, or like just create a set of numbers, and that's going to be 1, 2, 3, 4, and 5. All of these numbers are separated by commas. And so if I do that, we now see that there is a new object up here called mynums.v, and it says 1 through 5 because I've stored an object with numbers 1 through 5. And if I were to actually go down here and say, okay, mynums.v, it'll say, okay, yeah, here are the numbers that you stored in that object. This becomes more useful, like you can imagine, when you have an entire CSV that you want to store as an object, right? Like, because you don't want to have to write out the CSV every single time. You can store it and manipulate it after the fact. And so what you can actually do, another thing that you might want to test is like, okay, so how long is this object? Say you have a really, really long list of numbers. What you can do is, in the console, what I do is I just do length mynums.v, and if you hit enter, it's going to say 5, because there are 5 objects in that, 5 numbers in that object. You could also say something like, okay, what is the class of mynums.v? And it's going to say numeric, because this is a numeric object. It's all numeric data. If we were to do the same thing with what is the class of test.v, it says that it's character data, right? Which we would expect because it's a series of letters instead of a series of numbers. Everyone feeling good so far? Okay. So again, we're storing all of our objects up in this global environment. The other thing that we're going to be using today is this lower pane that involves files, plots, packages, help, and viewer. By the end, we will be using this plots. It might not be defaulting to that for you for right now, but anytime that you have a plot that data that you want to plot or create a visualization of, it's going to show up in that lower right-hand corner. So the scatter plot, whatever you've created, will show up there. And then once you have an image, you can export that image in various formats. And so the packages, this is going to be really helpful. We're not going to be using any today because I find that sometimes trying to install packages, like people have weird setups and it causes problems. So we won't be using any today, but I do want to talk a little bit about why they're useful. There are going to be a whole bunch of them that are automatically installed for you, but what you can do is call them into a session. So for example, one that we're not using today, but I wish we were, you will see why by the end, is this ggplot2. So if you are ever doing data visualizations, ggplot is going to be the best way of creating pretty visualizations. R has its own native mechanism for creating visualizations, but it is not all that elegant. It is a little clunky and isn't all that pretty. So, if you're doing a big data visualization project, you might want to use ggplot2. And then there are also other ones, like if you're ever doing web scraping, HTTR, I think some people pronounce it hatter, is used for getting URLs and, web scraping. And then there are other ones too, if you're working with XML data. There's an XML data one. I think that there are some for, I use most of these ones down here that are like for text analysis, text mining package, et cetera, et cetera. So these are definitely something to look through when you're starting an R project is, okay, what packages do I want to use for my project? All right, and then the final one that I want us to take a look at is this help. And anytime I'm using a function that you're unfamiliar with, definitely ask me during the session. But if you're ever at a point where you're trying to figure out, I don't actually know what this does, what you can do is down in the console, type in the name of any function preceded by just a question mark. So for example, if we wanted to know what is the plot function, we just do question mark plot and hit enter. And RStudio has this really handy dandy documentation viewer. So it'll take you to this help pane with the full documentation for anything that you would want to use in R. It's really, really helpful. I would definitely recommend using that, but I wanted you at least to know that that was there. All right, so let's take a look at our data that we can now start bringing into the session. So what I mentioned is helpful to do, and I know we all didn't have time to do this, but I would recommend putting a directory like on your desktop or something that you can find easily. And I called mine RSTEM because it's for this RSTEM workshop, and I put the data inside of that folder. So if you do that, it can make it a lot easier for you later down the line, and I tend to save my R scripts in the same place as I store the data because it's just kind of like one-stop shopping for both the data and what's being analyzed. So once you've done that, let's just take a look at this CSV. It is not the best in my opinion, but we could definitely have stored things a little bit better. But let's just talk a little bit about the data itself. So what we have is this column over here. If you were to open it up in like a plain text editor, it would be in the normal CSV format with the comma separated values. It's just a little bit easier to see it in tabular format, I think, for the purposes of today. But we see that we have this total biofuel production between 2000 and 2010, and it's by 1,000 barrels per day. The data documentation is not super great for this particular data set, but what we have over here is a set of regions in this column A, and then column B is 2000, 2001, all the way through 2010. Does anyone notice anything about column A that might actually be a little bit confusing for the purposes of analyzing this data that we would need to keep track of? And I'm looking specifically at like row 2 and row 9. Yeah. Yeah, it's like aggregating essentially data from multiple different countries and then actually listing out those countries underneath it. So, if we were to assume like, oh, okay, if we just sum up the rows, right, like that'll be information we need, but actually it's duplicating the data, which that's a good thing to know. And then what about the way that this graph is treating data that or instances where it doesn't have data for that given year? What are we noticing? Yeah, there are NAs, but is there anything else? Yeah, they're dashes. They're dashes, and I can make this bigger. So that is important for us to know, and we will be coming back to that. Okay, so now back to the R environment. So what we're going to do now is we want to do a thing called setting a working directory, and so there is a way of doing this in the console, but I'm going to use the GUI just because I don't want to have to deal, like it treats different operating systems differently. So what we're going to do right now is we are going to go to session up in the top, and then we're going to go to set working directory and then choose directory. I'm going to leave that up for a second. Okay. And so then it should bring up something that looks like, anytime you're going to choose a file, right? And so what I'm going to do is you're going to navigate to where you put your data. So if you kept it in your downloads folder, just make your downloads folder the working directory. But for me, because I moved it into its own directory, I'm going to say desktop and then RSTEM. And then you just hit open. And what you notice is that on the bottom in the console, it has added this set WD And then for me, it's the tilde/ desktop rstem. Yours is probably going to be like a C:/ because we're on different operating systems. But what I like to do is if I'm creating a new script and I want to remember, oh, okay, like where is the data at? Like where am I working? I tend to just put that at the top of my script, and I'm going to delete this up here. So this is actually a good thing to mention. You can open like things like Excel files, but it's best to say work with CSV files because that's going to be both a non-proprietary format and just a plain text format. So everything's stored as characters, none of it's stored like in a proprietary format. So if you can keep it as CSV, that would be ideal. Just don't save it as a numbers file. So as long as you it will, if it's stored as a CSV, it'll open it as a CSV. We'll get there and we'll see if you have an issue. But don't actually open the data set itself. Just open the directory that's above, like the folder that encloses. Save it wherever you're going to be able to find it easily. Yeah, so whatever folder contains that data file, that's going to be your working directory. So if you kept it in downloads, set your working directory as downloads. Once we have our working directory set, what we can do, what I like doing is I like just making sure that I keep that somewhere in the script file that I'm going to save. And so I'll just paste that up here. And what I'm going to do now, just to do my due diligence, is I'm going to actually save this as, and I'm going to keep it in that rstem directory, or again, keep it in the same directory as where your data is, and I'll just call this one biofuels 2, because I already have one in there. Actually, I'm going to open up mine, because I'm probably going to do a little bit of copy pasting so that you don't have to see me type all of the time. I know that that's not fun. Oh, I just copied the line. So I just highlighted it and then Control C or Command C and then paste. Control V or Control C. You don't have to do it. It's not super, super necessary. It's just a project workflow thing that I like doing. As long as it's down on the console, you should be good. Okay. So now what we're going to want to do is we have our working directory set, and that means that basically R is living in the environment of that folder. So it's going to be reading files that are in that space. And so what we can do now is we can actually go into that file and read the CSV that we have stored there. So the convenient thing about R is that in order to read a CSV that is somewhere in a directory, that command is literally just read.csv. It's quite self-explanatory. And then what we need to do is give it the file name in quotes. And so if you remember, we had that really, really long file name. It was total biofuels production. So if you start typing that in, you might even get like a little drop down that basically tells you what files are in there. So if you do that, it should look like this, where we have, you might have biofuels R, you're probably going to have R history, and you're definitely going to have this total biofuels production. This is nice. Again, you just hit tab and it'll bring up that suggested text. And if you just hit enter, it'll bring that up. So you don't need to actually type out every single thing. Yeah, so that's the file name. That should show up. And I realize that this is not very visible. I'm so sorry. I'm like looking from the audience. It's really hard to see, and it's not even like a sizing issue. It's just that it's kind of washed out. So maybe there are ways of, in preferences, changing the appearance. This is good for my eyes. Like I like that kind of papery one, but maybe we need something that's a lot darker. Is that more legible or less? More? Okay. Or maybe just like black and white, if I can find that. How's that? Better? All right, so now that we have this read CSV, what we could do is up here, just hit Control Enter. And what it's going to do is it's actually going to send down this entire CSV into our console. And it's just going to, again, all of those region names, all of these numbers, and it'll say eventually like reached maximum print because it's not going to fill up your entire console with everything. But you'll also notice that it hasn't added anything to the global environment. So it's not like we've stored that data set. All we've said is just read it and then it just prints it out. So what we're going to want to do here is actually create a variable that we can store this data in so we can save it for later. I'm going to call this one biofuels.df. I can talk a little bit about why I do that naming convention later, but once we've done that, what we're going to want to do is also include information about the rows and the columns that are row names and column names. And so what we can do here is actually say row names equals 1. And what that's going to say is that the first column is all just going to be those row names. So again, the row names are going to be all the names of the countries and all the names of the continents. And actually, sorry, this is where I'm going to do a little bit of copying, pasting. Oh, and so the other thing too is we're going to want to say that there is indeed a header in here. And so that's going to be true. So if we hit Control Enter, what we're going to see is that now our environment does have a new variable in it. And so it's called biofuels.df. And what we can do now is we can test out some things about this biofuels.df. And I'm going to do this down in the console because it's not something I necessarily want to save. So if I say, what is the class of biofuels.df? So like what type of object is it? We had already character and integer, or numeric rather. So if I hit enter, it's going to say data frame. And basically what a data frame is in R is going to be like, it's a tabular format that can deal with both numbers and characters very well. So that's useful. And so the other thing we might want to test is, okay, what are the dimensions of the data frame? So like how big is it? And what we do, how we do that is with this dim, and we're going to say biofuels.df, and it should give everyone 232 by 11. Is that the number you got? So now what we're going to want to do, in order to do any type of numeric, calculations on any of the fields, what we're going to need to do is actually make sure that all of our files are being, all of the data is actually being stored as numeric data. So one way that we can do that, a convenient thing about this environment pane is if we actually just click on an object, it will bring up a nice thing that looks kind of tabular. It looks a little bit like Excel, and it's going to give us kind of what we saw when we opened it up in Excel, right? So we have this North America, Bermuda, all of these different places, and then all of the data about the countries. And so what we can do is hover over this and test to see whether or not it's being stored as numeric. So if we hover over the column names, what we're going to say is column 1 factor with 19 levels, factor with 24 levels. And so actually this is not being stored as numeric. And I will give you this one. If we were to actually try to do any calculations on these numbers in here, it'll get mad at us. And so there are two things that we need to do in order to actually fix this. We're going to need to go into this read.csv. And if we go to the end after we've done row names 1 and header true, what we're going to need to do is say is.na. So we're telling R here what are the ways that this particular file is saying, hey, this is an NA character or an NA cell. So like there's no data. So does anyone remember what those were in our file that we worked with. Whenever we had data that didn't have data, there were two ways that it, it was dash dash or NA. And so the way that we're going to do this is once we say is.na, we're going to use that C function or concatenate that I was talking about earlier, or combine, I forget, yeah. And so we're going to say C, and then we're going to say NA. So NA is indicating that there's no data, and then also comma, and then dash dash. So we have now given it two different values for what indicates not applicable. And then following this, we are also going to put another comma followed by strings as factors, and we are going to say false. So we don't want all of these strings, like all of the names like North America and Bermuda, to be treated as factors. We want them to be treated as characters. This is just like a weird quirk of R. But now, if we run that again, biofuels, it's still going to say 232 obs of 11 variables. But if we were to actually click on that again and open it up as in this kind of tabular view, if we hover over this, oh, and of course, it's not going to work for me when I show you that. Let me try this instead. Sorry, guys. Try to show off something and then it doesn't work in the moment. I'm going to try as.is instead. As.is true. And so if you were to change that strings as factors to as.is equals true, and then we click on this again, ideally what should happen is that it should say not at all what it should be saying. Why is this not working? I'm so sorry. Huh. Have you ever had a feeling of panic where you're like, I've done everything correctly, what is happening? Oh, sorry. I know what I did. I mixed up is NA with NA string. So what you're actually going to do, where it says is NA, you're going to say NA dot strings. That was a total mind fart on my part. Sorry about that. So once you do that, once we open up biofuels.df and you hover over that, it's going to say column 1, numeric with range 0 to 314. So basically all that's saying is that this is kind of like the range of numbers that exist. Apologies for that little side track into La La Land. But anytime that you're working with a CSV that includes both numbers and letters, what you're going to need to do is make sure that you're actually coercing those numbers into, like, all the rows into numeric data, because otherwise you will try doing things like, what's the mean of all the data in this row? And it'll be like, you're working with a bunch of character data. I can't, do anything with that. So that's just really important to do for numeric data when you're working with CSV. Something to keep in mind. Okay, so this is where Sarah is really going to start pulling from her sample file, because otherwise what's going to happen is I'm going to end up mixing everything up. So now what we can do is we can actually kind of take a look at this biofuels.df. And one thing that's kind of fun is that we can actually select by row names, by column names. So if we do this biofuels.df and then we type in a $, what it actually does is it brings up all of our years. And so we can actually say, okay, I want to look at everything that happened in 2004. And if we hit enter or control enter, what it's going to do is it's actually just going to bring us this massive set, this entire column. Mm-hmm. sorry, this is going to be a $sign. So if you say biofuels.df and you type in a $sign, it's going to bring up all of these years that you've entered. I did 2004. You can pick any of them. I just wanted to show you that if you select any one of them and you hit Control Enter, it's going to give you that entire column. So this is a really great way of selecting that column data. It's a convenient way of basically finding all of that. Another thing that you can do in R is, so we're working with this kind of, what we can do is subset using square brackets. So if we say biofuels.df, what we can do is we can find, so for example, if we want to find North America in 2003, which is going to be the first row and the fourth column, what we can do is in these subsetted brackets, we can say, okay, what is 1 and 4? And that will bring up 187. So again, we're looking at that North America, and that is what we would, actually it is not what we would expect, because I said 2004, but I meant 2003. But yeah, 2003 is row 4. And that will bring up that number. Another thing that is very useful is that instead of, like, it's kind of a pain in the butt to need to actually have to like figure out, okay, what row is, I don't know, like North America in, we can actually select by row names. So actually what we did earlier when we were saying row names are in column 1, if we were to actually say, okay, what are the row names of this biofuels.df? And what it's going to do is it's actually going to, if we were to say, yeah, row.names and then in parentheses biofuels.df, it'll give us the names of all of these different things. So what we could do is actually use these row names instead of the numbers in this row bracket subsetting. So what we can do is we can say biofuels.df and then subset brackets, and then say we want to see, again, this world data, which is just going to be all that aggregate data. We can say world, and then just give me all of the data from the entire world, that last row. And if we just do comma and leave everything after the comma blank, it'll give us everything from that row. So what we can do here is see that we have, in 2000, this is really hard to read, just because it's too tiny, but in 2000 we had world production was at 314,000 barrels per day. And then by 2010, it's 1,855,000 barrels per day. Everyone feeling okay about that? Okay. I'm realizing that I'm going from asking if everyone's feeling good about it to everyone feeling okay about it, but okay. And so this all becomes useful if we want to, so for example, we already pointed out that there is this kind of weird convention in the CSV of both including country level data with wider region level data. So what we can actually do is create a new object that's just a data frame with all of that wider region level data, so continent ish level data. So I kind of did this all for you because it's a lot. But if you wanted to, and we don't have to do all of this, we can maybe just, if we wanted to create an Americas object where we only analyze things from the Americas, what we can do is create, I'm going to call it Americas.df. And what I can, what I'm going to do is just call it Americas. And does anyone remember how we create an object in R? What characters do we use to assign a variable? Yes, so it looks like a little arrow. And so if we wanted to get the region level data for both of the Americas, that's going to be, in this CSV, North America and Central ampersand South America. We do need to match the strings exactly, so let's do that together. I'm going to say, okay, let's see, combine North space capital A America and then in quotes, Central and South America. I'm going to create that object. And so now if we actually go over into our variables, we see that there is this value of America that is just North America and Central and South America. And what we can do is kind of like up here in biofuels.df where we have world, we can actually create a new data frame object that has both North and Central and South America all in one data frame. So we could analyze that separately. So the way we're going to do that is I'm going to say Americas.df. So it's a data frame. And what I'll do is I'll say biofuels.df, and then we're going to, again, use that bracketing for subsetting, and we're just going to say Americas. So we're only going to find the rows that have the headings of whatever object is stored in the Americas. So again, North America and Central and South America. And if we just follow that up with a comma, and we're, again, just saying, get me everything in that row. So now if we hit Control Enter, we'll have a new data object called Americas.df. And what we see is that when we click on it, it looks almost exactly just like a smaller version, right, of the data frame that we created before. So we have all this over here. So we can further, do analysis basically just by subsetting and cleaning all of that up. So this is where all of the work that we've done earlier basically on creating everything and making sure that it is stored as numeric data comes in handy. So say we wanted to find the sum of all of the production in North America over the course of these 11 years. So again, from 2000 to 2010. What we can do is use this sum function, and what we can do is say sum of, and then we'll go back to using biofuels.df. And if we do that bracketing subsetting again, and so if we say North space America, and I can't type when people are looking, followed by, within that square bracket, just a comma, and we hit Control Enter, what it does is it sums up all of the data from that row across the entire thing. So we have 4,216. We can further attempt doing that, and I can tell you that this is not going to work, but we're going to do it, and then I will tell you how to fix it. So we can also do that with getting like the mean of a series, a bunch of data. And so if we try doing that, mean, and then I'm just going to actually copy this biofuels.df North America. Actually, you know what? It might work. Okay. So what this is saying is in mean default, this is something that you're going to encounter a lot when you're using R. It's like actually kind of a dark art parsing R error messages, and I would encourage you to learn how to do it. It takes time though. So we have this warning message first of all, it tells us that it's not applicable, it's not going to work. And so it says in mean default biofuels.df, argument is not numeric or logical. And this comes back to what we were talking about earlier with data types. And so it's always important to know what data type you're working with. If we want to actually test out what data type we're working with right now, we can, just down here say class. And then we can actually, I'm just going to copy it because it's easier, but biofuels.df and then North America. So it should be all of that numeric data. It worked on some, right? But if we actually type that in there and we hit enter, it's going to say, oh, this is a class of data frame. And what it needs to be is a class of numeric. And so what we can actually do just to make this work properly is just say, if we go to mean, inside this parenthesis here, there's this really convenient function called as.numeric. And so we can put that in there, start parenthesis, and then end the parenthesis again at the end. So it's going to be 2 parens and a square bracket at the end. So it's mean as numeric biofuels.df. So we're converting this data frame into a numeric object. And if we hit Control Enter, that's when it gives us the mean across all of that row. So we see that the mean is 383 point, etc. Okay. How we doing? Okay. So maybe I always find that plotting is a lot more fun than anything else because you actually get to see some visualizations. So say we wanted to basically learn, do a visualization, create a visualization of 2 of the larger-ish countries who are producing biofuels. So in one of them, of course, it's gonna be the United States. And then if we go down a little bit further, we see that Brazil is actually producing a lot of them as well. So if we want to create basically an object that allows us to plot that, what we're going to need to do is, again, do what we had done before and store that row as its own separate object so that we can analyze it. So what I'm going to do is call this one United States.df, and we'll assign that as a variable. So it's going to be a less than sign and a hyphen. And so then I'm going to say, okay, biofuels.df, and then find me the row that has the heading United States. And again, that comma, because we're getting all of the cells from that entire row. You could alternately say 1 through 11. That would get all of the cells in the row, but if you leave it blank, it'll just get everything. Okay, and so if you hit Control Enter, it'll create a new object called United States. Again, we can click on that and see what happens here. And we see that it gives us this single row data frame. When we want to do plotting in R, we're actually going to need everything to kind of be in reverse. And so what we need to do is actually transform that object. And so the way that we do that is with this T function. So if we want to say, I'm going to call this one US transformed. And I'm again just going to assign that variable less than hyphen, and we'll just say T for transform United States.df. If we hit enter, it's going to create this new object. And if we click on that, what you see is it's just switched the X and Y, right? So now we have one column of United States followed by all the years. And so with this, what we can actually do is use the plot function to actually create a visualization. So I'm just going to create a really basic one. I'm going to say plot US transformed. And I'm going to say that it is of the type of B. B stands for both lines and points. So it will give us lines and then also points for each individual thing. And so now if we hit Control Enter, it's not gonna, figure margin's too large. This error literally just means your plot space is too tiny. You gotta make it bigger. So I will do that presently. Okay, and if we try that again, what it'll do is it's created this very tiny graph that isn't all that helpful for us, but if we make it even bigger, we do see this 200 and 600, and I think there's an implied 800 up at the top. And what it's done, though, is it's just given us, those lines and points, and then what it's done is it said 2, 4, 6, 8, 10, which isn't really what we wanted because these really should be years, right? Like you'd figure that would be 2000, 2002, et cetera, et cetera. And so the way that you would do that, it's actually a little bit backwards, but what we can do, and this is another reason though that you want to kind of explore other packages because there are some that are more robust in terms of visualization. This is just the kind of out of the box one that you get. But what we're going to do is actually just suppress the X labels with this XAXT, and we'll put N in there, and that will essentially suppress it. So if we were to hit enter again, we see that that whole bottom row goes away, which is really convenient. And so now we do want it to have a label of some kind. And so what we're going to do is use this access function, and I'm just going to copy this so that you don't need to watch me type. No. And I'll explain what it says. Sorry, I'm gonna bring this up a lot. So if we were to actually, if we wanted to know, okay, like what does this access function even do? We can, again, do that question marks followed by access. If we hit enter, it's gonna bring us over to the documentation. It'll tell us everything about it. And so this first argument on access is going to be side. And you see in mine that I've put 1. And if we look down in the documentation, we can actually see, oh, okay, so side means either below or to the left or above or to the right. And so we want to actually relabel that axis below. So we're going to use 1. And then what I've also done is at 1 to 11, because there are 11 rows. We want to say how long this is going to replicate over. So it's going to be for 11 spaces from 2000 to 2010. And then what we can do is say what we want it to be labeled with. And so here, this labels function is going to be equal to row names, and we need to say, I changed the name of this, but it's going to be row names of US, US transformed. And so if we hit enter on this, what it's done now is it's relabeled this, right? So 2000, 2003, 2006, 2009, which is what we wanted. We wanted to be able to relabel all that information. And so that's kind of interesting, I guess. But what if we wanted to actually visualize, maybe the United States against that country, that, like we talked about, analyze it against Brazil? What we can do, now that we have US transformed, we can apply the same principle to Brazil. So what we're going to do is we're going to create a new data frame, and I'm going to call it Brazil.df. And that's going to be, as above, this biofuels.df. And then we're finding that row name of Brazil, and it's going to be exact character match, so we do need to capitalize it like it is in the row name. Followed by a parenthesis. Or sorry, by a comma. I know my punctuation. And if we hit enter, we're going to, again, need to do that same thing, because if we have the Brazil object, again, it's as a row, and we need it to be in that column format where Brazil is the column name. So all we're going to do is Brazil, I'm going to create that I'll call it Brazil transformed.df, and all I'm going to say is T Brazil.df. So just transform that so that X becomes the Y and the Y becomes the X. So now what we can do is we can add lines onto this plot using the lines function. But the first thing I'm going to do is actually, I'm going to create this graph to have 2 different colors so that we can actually visually see the difference between the two. And so what we can do over here is in our plot US transformed type equals B, we can add on an additional argument called COL for color. And we can pick basically any, I think, HTML color name. So for this one, I'm just going to use blue. And if we hit enter, it's going to change it to blue. And you'll notice it took away our nice labeling system. That just means that we need to run this axis again, and it'll reintroduce it if I can type. And so that's all reintroduced. Now what we can do is we can add lines, and this is going to look very similar to this plot up here, sorry, okay. And now what we're gonna say is Brazil transformed.df. We're gonna say that it's gonna also be type equals B, because we want it to have both lines and plots. And then what we can do is this comma followed by color, and for this one we'll say color is gonna be green. How about that? All right, and if we hit Control Enter here, what it's done is it's created, again, a nice extra line that's showing us Brazil. And so what we see is actually in the early 2000s, they were ahead of us on the production of biofuels, but now we have way outstripped them in terms of that. So because I know that there have been a lot of technical difficulties throughout this, what I want to do is, for those of you who are feeling confident, try playing around a little bit with the data. And I think what we can do for the next 20 minutes is hands-on and troubleshooting. I don't know if we should probably not keep the recording going for this. But thank you all for your patience. I'm sorry that, there are always technical difficulties with these types of workshops, but I want to make sure that I am available to come around and answer questions for those of you who have them. Thank you so much.